Now that we've reviewed graphing linear equations, now we're going to talk about systems of equations. A linear system consists of several linear equations. Sometimes it's 2. It could be 3, 4, 10, 100. We're going to focus on systems of 2 linear equations. So a system of equations is 2 or more related unknowns that you can represent as a system of equations. The solution of a system is going to be the set of values for the variables that make all the equations true. When we graph 2 linear equations on the same coordinate plane, the solution is where the graphs intersect. So let's do an example of graphing. So in problem 1, I want to find the solution of this particular system. Negative 3x plus 2y equals 8. X plus 4y equals negative 12. I'm going to do this by hand, but we'll also talk about in class how to do this on the graphing calculator. In order to graph this by hand, I want to put both of these equations in slope-intercept form. So the first equation, I'm going to add the 3x, and then I'm going to divide by 2. So the first equation, y equals 3 halves x plus 4, has a y-intercept of 4, and the slope is 3 over 2. So I go up 3 to the right 2, or I can go down 3 to the left 2, and I'm going to do that a couple of times just to make sure I have a nice line here. So here's my line. For the second equation, in order to put it in slope-intercept form, I'm going to subtract the x, and then I'm going to divide by 4. So I get y is equal to negative 1/4 x minus 3. The slope, or the y-intercept, is at negative 3, and the slope is negative 1/4. So that's down 1 to the right 4. Or I can go up 1 to the left 4. Oops, let's draw that a little bit nicer. And there's my line. I guess that point should be there. The point where the 2 lines intersect happens to be here at negative 4, negative 2. Negative 4, negative 2 is the solution to the system. If you were to plug that ordered pair back into both of the original equations, it would make both of them true. The solution to a system of equations is the ordered pair that makes all the equations true. On the graphing calculator, if you want to find the ordered pair that makes both equations true, you would graph both of those systems. So I would graph y1 equals 3 halves x plus 4. And then in y2, I would graph negative 1/4 x minus 3. Then I would go to the table function. What you do in the table is you look for, it gives you x, and then the next column is y1, and then the next column is y2. So as you're looking in those columns, you want to look for the x value where both the y values are the same. There's only going to be one point. And that point is going to be when x is negative 4, both of these go through y is negative 2. So on the graphing calculator, you can find the solution by going to the table and looking for where y1 and y2 have the same y value. There were 3 things that could happen when you graphed a system of equations. One thing that could happen is you could graph the 2 lines. They intersect at one place. We say that has one solution. And the solution is the ordered pair where the 2 lines intersect. But if you have 2 equations, another thing that could happen is the lines could be parallel. Well, parallel lines don't intersect. We say that this has no solution because there's no ordered pair that's going to make both the equations true. But there's a third thing that could happen. It's possible that I could give you 2 equations, and those 2 equations are the exact same equation, in which case when you go to graph them both, they're really just the same line. When that happens, we say that the system has infinitely many solutions. That means that every ordered pair on the line makes both equations true all the time. I claim to you that we don't need to actually graph them to determine how many solutions there are going to be. You may have to graph it to find the solution, but I can tell you if a system has one, no, or infinitely many solutions by doing a little bit of algebra. So let's do a problem where we're going to show how you don't need graphing in order to determine how many solutions there are. I want to figure out how many solutions there are to the system 4y minus 2x equals 6, 8y equals 4x minus 12. What I'm going to start with is I'm going to put both of these in slope-intercept form. So in the first equation, to put it in slope-intercept form, I'm going to add 2x, and then I'm going to divide everything by 4. When I divide everything by 4, I get 2 over 4x, which reduces to 1/2, and I get 6 over 4, which reduces to 3/2. The second equation, y is already by itself, so all I have to do is divide everything by 8. 4 divided by 8 is 1/2. 12 divided by 8 is 3/2. Now, I want you to look at both of those equations and notice something. They both have the same slope. And we know that lines with the same slope are parallel. But we have this third thing that can happen, which is you could get infinitely many solutions if the two equations are exactly the same. That means they have the same slope and the same y-intercept. Well, the y-intercept is not the same. Notice that b here is positive 3/2 and b over here is negative 3/2. So as long as the y-intercepts are different, but the slopes are the same, they're parallel. And if they're parallel, they have no solution.